Good afternoon, everybody. For the day, I'm going to do a hypothesis testing for mean with sigma known, which you started last time, and I'm going to finish it, and then I'm going to do a hypothesis testing for mean when sigma is unknown using student t-distribution. That's what it is. So let's get started with this first problem. According to Pew Research Center, on the average, an American reads about 12 books per year. Let's assume that the population standard deviation is 3. Okay, so your sigma is 3. So sigma is equal to 3. You surveyed 40 people, so that means your sample size n is equal to 40 in your city, and found that average was 9 books per year. So the average of these 40 people, that would be x bar or sample mean, is 9. At 0.05 significance level, so that means your alpha is 0.05. So at 0.05 significance level, test the claim that the average number of books read by a typical American per year is less than 12. So mu is less than 12. That's going to be your alternative hypothesis because it does not include the equality part. And also this is what you are trying to figure out. And mu is greater than or equal to 12. That's the default assumption or null hypothesis. So I think I've got everything that I need in order to solve the problem, in order to do the hypothesis testing. So step number 1, our normality condition, right? So what is the normality condition? It has to be bell-shaped or normally distributed. The problem, however, doesn't tell you that it is bell-shaped. Now, is it likely that we cannot do the problem, or is there any other information in the problem where we could say, oh, okay, we can use that information to make sure that normality condition is met? So I kind of would like to get your feedback on that. If you please let me know. The problem specifically does not tell you that it's normally distributed or bell-shaped. All right, it doesn't tell you. So now, for us to be able to do hypothesis testing, we have to have a distribution that is bell-shaped or normal. And how do we ensure that? Anybody? How do I make sure of that? So I see a comment. Sample size is greater than or equal to 30. Perfect, Lupi. So your sample size n is equal to 40, right? Which is greater than or equal to 30. If your sample size is greater than or equal to 30, you can use the central limit theorem, even though your initial population may not be bell-shaped, but your sampling distribution of the sample means will be bell-shaped. So that is what the reason is. And number 2, null hypothesis is mu is greater than or equal to 12, and alternative hypothesis is that mu is less than 12. And step number 3, which is your test statistic Z star is equal to x bar minus mu divided by sigma over square root of the sample size. And we have everything that we need. Z star is equal to x bar is 9 minus mu is 12 divided by sigma is given to be 3. All of it divided by the sample size, which is 40. So Z star is equal to 9 minus 12 is negative 3 times square root of 40 over 3. So Z star is equal to negative square root of 40. And that is roughly about 6.32. Z star is equal to negative 6.32. Negative 6.32. All right, that's what it is. Now we do the other thing, which is the critical region, step 4, CR or critical region, and we do the bell-shaped curve. Mean 0, standard deviation 1. Here, do we do two-tailed test or one-tailed test? Which one? Can anybody help me? Which test do we do? Two-tail or single-tail? One tail, George. Okay, which tail and why? Which tail would that be? It's going to be the left tail, not the right tail, George. It's going to be left tail because the alternative hypothesis is less than. So we're going to be doing left tail test. And area on the left should be equal to alpha, which is 0.05. So associated with 0.05, your z-score is going to be negative 1.645. So your critical region is going to be everything to the left of this. So critical region is from negative infinity to negative 1.645. And step number 5 is conclusion. Now your test statistic Z star, all right? Test statistic Z star is negative 6.32. So it's going to be somewhere around here, way out there, negative 6.32. Test statistic Z star is negative 6.32, is in the critical region. The critical region, negative infinity to negative 1.645. So I reject the null hypothesis, which is H sub 0, that mu is greater than or equal to 12. So at 0.05 significance level, you reject the null hypothesis that average number of books that Americans read per year is greater than or equal to 12. And that is how you will do this problem. Any question, anybody, on this problem? Okay.
How would you know if you need two tails or one tail?
You look at the alternative hypothesis. If it is less than, you do left tail. If it is greater than, you do right tail. If it is not equal to, then you do both tails.
Okay, I see. Thank you.
Any other question from anybody? Okay. Now let's go ahead and have you work on the next problem. Everybody, please spend a few minutes, work on this problem, and then I'm gonna go ahead and work it here. According to USA Today College, an American college student studies about 17 hours per week with population standard deviation 4 hours. So mu is 17, I guess, right? Mu 17 and sigma is 4. You'd like to know if a similar trend is present at your school. So you surveyed 100 students. So your n is equal to 100. And found that their weekly average was 15 hours. So X bar from these 100 students is 15. At 0.10 significance level. So alpha is equal to 0.10 significance level. Test the claim that average number of hours students spend studying in your institution is less than 17. So mu is less than 17. That's what you're testing. So that's going to be your alternative. And your null is going to be mu is greater than or equal to 17, which is null hypothesis. You have all the information that you need in order to solve this problem. So what is it? Number one, normality condition. Your n is equal to 100, which is obviously greater than or equal to 30. So according to central limit theorem, sampling distribution of the sample means of sample size 100 is bell-shaped. Number two, your null hypothesis is mu is greater than or equal to 17, and your alternative hypothesis is mu is less than 17. Step number three, your test statistic Z star is equal to X bar minus mu divided by sigma over square root of the sample size. Z star is equal to X bar is something we found, 15, minus mu is 17, divided by sigma is 4, right? Divided by square root of the sample size means square root of 100. If you do the math, you're going to get Z star is equal to 15 minus 17 is negative 2 times 4 divided by square root of 100, which is 10, by the way. So it's going to be 10 over 4. 2 goes into 4 twice, 2 goes into 10 5 times. So your Z star is equal to negative 5. Your Z star is negative 5. Now, let's go ahead and do the rest of the problem. Step number 4, your critical region, bell-shaped, right? Mean is 0, standard deviation 1. Now look, alternative hypothesis, it tells you that mu is less than 17. So that's what you're testing. So this is left tail test, and alpha is 0.10. So this is going to be just 0.10. If you remember, the z-score associated with this is negative 1.28. So we are talking about all the area to the left of negative 1.28 all the way up to negative infinity. So your critical region is going to be negative infinity to negative 1.28. In step number 5, you're going to be doing conclusion. All right. So the conclusion is that Z star negative 5, Z star is equal to negative 5. Where does it fall? It's probably somewhere here, negative 5. Z star is negative 5 is in critical region, negative infinity to negative 1.28. So reject H naught, which is mu is greater than or equal to 17. This process is pretty standard. Once you get the hang of one of them, I think rest is pretty straightforward. There is really nothing to worry about. It's very, very simple. Nothing out of the ordinary.
Did you get negative 1.28 again?
What is it? Sorry, hold on.
How did you get negative 1.28?
How do I get negative 1.28?
Yeah.
It's from the z-scores table.
Oh, and you're I see. And you're just supposed to find 0.10. Okay.
Yes, yes.
Does the and the 5? Yeah. Okay. Okay. I see. Okay. Thank you.
Okay. Now let's do the next problem. Again, I'll give you a couple of minutes to work on it, and then I will go ahead and do this. Everybody, please work on it a few minutes quickly. So according to www.textrequest.com, an American between 18 and 24 cents and receives about 128 text messages per day. Assume that the population standard deviation is 20. So that means sigma is 20. To test this, you take a survey of 100 adults. So n is equal to 100. In this age group, of course, and you find that their average or X bar is 120. At 0.025 significance level, so that means your alpha is 0.025. At that significance level, test the claim that the average number of text messages young adults sends is less than 128. So you want to check whether mu is less than 128. And this does not have equality. So remember, this is going to be the alternative, and complement of this is going to be greater than or equal to 128, mu greater than or equal to 128. That is going to be your null hypothesis. We have all the information that we need in order to do this. So number one, normality condition, bell shape, right? N is equal to 100, which is greater than or equal to 30, so you're good. Number two, null hypothesis. Null hypothesis is mu is greater than or equal to 128, and your alternative hypothesis is mu is less than 128. And step number three, is test statistic, right? Z star is equal to X bar minus mu divided by sigma over square root of the sample size, and Z star is gonna be equal to X bar is 120,
It's
right?
120 minus 128 divided by 20, and then divided by again 100 square or 10.
Square root, yeah. So Z star is going to be 120 minus 128 is negative 8 times square root of 120 is, 100 is 10 divided by 20. 10 goes into 20 twice, 2 goes into 8 4 times, and your Z star is going to be negative 4. So your test statistic is negative 4. Now you're going to go ahead and do step 4, where you find the critical region. So your bell-shaped curve.
For the 0.025, it's negative 1.96, right?
Yes.
Okay.
So now you have to ask yourself the question, which tail are you dealing with? Look at the alternative hypothesis. It says mu is less than 128. So we are looking at the left tail. Less than means left tail, greater than means right tail, and not equal to means both tail. And the alpha is given to be 0.025, 0.025, okay? And this point is negative 1.96. So your critical region is everything to the left. So critical region is negative infinity to negative 1.96. Now, step number 5, your conclusion. Step number 5 is your conclusion, which is what? Your test statistic Z star, right? Z star is equal to -4 is in the critical region, because -4 is going to be somewhere here around here. Is in critical region -infinity to -1.96. It is in the critical region. So reject null hypothesis, which is this guy. Mu is greater than or equal to 128. There you go. That's how you will do it. Does it make sense, guys? Do you feel confident that you could do these types of problems on your own?
Yeah, 100%. Yeah, this is all it is just plugging in again. Like it's like it's like simple. Like all you have to do is just find a. All you gotta do is just know what goes what, and then just plug it in.
Yes. Okay, great. Now we are going to do hypothesis testing, but we're going to do hypothesis testing for mean, again, mu, right? But this time we don't know sigma. Sigma unknown, meaning we are going to have to use sample standard deviation. Structure is exactly the same. And look at the difference between two formulas when you know sigma versus you don't know. It's x bar minus mu divided by sigma over square root of the sample size. That's what for when you know sigma. But if you don't know sigma, you use student t distribution, or t star is equal to x bar minus mu divided by, just instead of sigma, because you do not know sigma, you use s. That's it. That's the only difference. Other than that, everything is the same process-wise. There is slight difference in finding the critical values for t, but that's not a big deal. You already know how to do it, so you just have to follow that. So let's do this problem first. Okay. For this one, I want you to read the problem. Take a minute and read the problem and try to make some sense. You'd like to test the claim that an ordinary ag field worker in Salinas, California makes $15,000 per year, a boundary for federal poverty level, FPL. So you take a random sample of how many people? 10 people. So your sample size n is equal to 10, and n is equal to 10. Okay, and you got this data where x bar, average of these numbers, is 17,340, and the sample standard deviation s is 3514. There's decimal after that, I just ignored that. So it's 3514. And also make assumption that the distribution of incomes of the field for the field workers is bell-shaped. So that's normal distribution. Okay. At 0.05 significance level, so alpha is equal to 0.05. At 0.05 significance level, test the claim that the average income for the field workers is different than 15,000 per year. So you're testing either mu is equal to 15,000, which is going to be your null hypothesis, versus mu is not equal to 15,000, which is the alternative hypothesis. And that's what the information. So you collect the information, write everything down, and then you can start working. So number one, normality condition, you kind of have to assume bell shape, all right? So that's given in the problem. And number two, null hypothesis, which is mu is equal to 15K or 15,000, right? And your alternative hypothesis is mu is not equal to 15,000. Mu is 15,000 versus mu is not equal to 15,000. And step number 3 is your test statistic. So this is where things are a little different. Instead of Z star, I use T star just to indicate that we are dealing with T distribution. X bar minus mu divided by, instead of sigma, you have to use S, or sample standard deviation, divided by square root of the sample size. This is the only difference here, sample standard deviation in terms of structure of the formula. So your T star is going to be equal to X bar is 17,340 minus mu, which is 15,000, all of it divided by the sample standard deviation, which is 3514. That is divided by the square root of the sample size, which is 10. If you do the math, you will get 2.11. T star is equal to 2.11. I rounded it to 100 place, of course. So your test statistic is 2.11. Now in step number 4, you're going to find the critical regions. Now these critical regions are for T distribution, not for standard normal distribution. So T distribution, as you know, is kind of like a flattened bell-shaped curve, kind of like that. You can think of it that way. And your alternative hypothesis is not equal to, which tells you that you have to do a two-tailed test, okay? So your alpha is 0.05. So your alpha over 2 is 0.025. Alpha is 0.05. Alpha over 2 is 0.025. So your right tail is going to be 0.025, and your left tail is going to be 0.025. Now, everybody look it up in the standard normal, not standard, student T distribution table. Now, you'll need two pieces of information: degrees of freedom, which is defined as n minus 1, which is 10 minus 1, that is equal to 9. So your degrees of freedom is 9. Your degrees of freedom is 9. Next, it's going to be area in one tail versus two tails. Area in one tail is 0.025. Area in two tails is going to be twice as much, or 0.05. If you look in the table that shows column area in one tail 0.025 and area in two tail 0.05, and you go down until you see row labeled 9, okay? Degrees of freedom, the first column, 9, you see that is 2.262, 2.262, and this is going to be negative 2.262. So your critical region should be negative infinity to negative 2.262 union 2.262 to positive infinity. Okay. That's your critical region. So now, step number 5, your test statistic T star, right? Your T star is 2.11. So which is probably somewhere here. 2.11 is not in the critical region, right? So reject null hypothesis H naught, that mu, oh, sorry, sorry about that. Do not reject, not no. reject because it's not in the critical region. If it is not in the critical region, you do not reject. If it is in the critical region, you do reject. So it's not in the critical region, so you do not reject null hypothesis that mu is equal to 15,000. And that's pretty much how you do the hypothesis testing for population mean when you do not know the population standard deviation. Very, very standard process, exactly like what we have been doing for last two classes, basically last class and up until now, this class. I am doing the same thing again and again and again, the same processes, exact same process, but we did it for proportion, we did it for mean when we knew sigma. Now we are doing it for mean when you don't know sigma. We use the sample standard deviation if you do not know sigma, and the distribution becomes t distribution. And that is how you will do this problem. Since this is a slight variation of the other problem, do you guys feel you're okay, or any question anybody has?
I know how you got 3,514 because it's a standard deviation, and you just have to plug in with all the numbers that they give you, right? Am I wrong? Is that how you do it?
What is it? Okay, I missed your question. You just enter what? All right. Okay.
I'm sorry. I had like a call. Right now. But so I know how you got the standard deviation because you just plug in all the numbers and it'll equal 3,514, right? Is that right?
Standard deviation, you just have to use the formula. I just did it in the
website.
At 1 o'clock. I did it, right? You can use the NumPy.
Mm-hmm.
So you just to do that, or you can Google it. There are websites where you do standard deviation for you.
Is
Or
that
you
how
can use it.
Is that how you got the X bar as well? For 17,340?
Yeah, you can find the X bar. X bar is just adding the numbers and divide it by the total number of data points.
Okay. I just want to make sure. Thank you.
Okay. Mm-hmm. All right. Next, another standard deviation problem. Here, I'll give you the information so that you can actually use it. For this one, I have the mean and the standard deviation. So let me just quickly find it. Mean is 44 here. X bar is 44, and standard deviation, sample standard deviation S is 19.90. Okay, so go ahead and everybody work on this problem. So I'll give you a few minutes to work on it, and then we'll go ahead and work together.
Yeah, I think I'm ready.
Okay. So how much time on the average students spend per day on Facebook? You asked 15 people, so your sample size N is 15. N is equal to 15. And their average is 44 for these 15 people. Okay, and standard deviation is 9.9. So you want to test that at what significance level? 0.05. Alpha is equal to 0.05. You want to test that mean amount of time or average amount of time students spend on Facebook is less than 30 minutes. So mu is less than 30 versus mu is greater than or equal to 30. So you've got all the information that you need. So you just do the things. So normality, so you kind of have to assume that in this problem, so I give it to you. Number 2, null hypothesis, mu is greater than or equal to 30, and alternative hypothesis is mu is less than 30. Number 3, you test statistic T star is equal to X bar minus mu divided by S over square root of the sample size. So T star is equal to X bar, which is 44, minus mu is 30, divided by S, which is 19.9, over square root of the sample size, which is 15. So if you do the math, what do you get? 14 divided by 19.9 times 15 square root 2.72. Your T star is equal to 2.72. Now, let's go ahead and do the critical region part. We're going to find the critical values for T distribution. Mean 0, right? So now area to the alpha is 0.05. Here, if you look at the alternative hypothesis is less than, so we are doing a left tail test. That's 0.05. And your degrees of freedom is going to be n minus 1 is equal to 15 minus 1, which is 14. Your degrees of freedom is 14. Now, you look it up in the table. This time, you look for area in one tail 0.05, and area in two tail is going to be 0.10, okay? If area in one tail is 0.05, area in two tail is 0.1, and degrees of freedom is 14. So if you look at the degrees of freedom column, go to 14 down that column, and then go right, keep going to the right, 1, 2, 3, fourth column, which is technically fifth column, you'll see 1.761, okay? So that's going to be negative 1.761. So your critical regions are going to be from here to negative infinity. So critical region is from negative infinity to negative 1.761. And step number 5, your conclusion. Did I make a mistake anywhere? No. Conclusion. Let's see, mean is 44 and everything. Okay, looks good to me, unless I'm missing anything obvious. Obviously, this number is positive, which is somewhere here, right? 2.72. It is not even in the critical region. So T star is equal to 2.72 is not in the critical region, negative infinity to negative 1.761. So reject or do not reject? What do you think? Do we reject or we don't reject? It's not in the critical region. You do not reject. Exactly. Thank you. So do not reject H naught. Okay. What is the H naught? H naught is mu is greater than or equal to 30. Mu is greater than or equal to 30. People spend more than 30 minutes on the social media.
How do you know when you're using z-score and when you're using t distribution critical t values?
When you don't know population standard deviation, that's when you use t distribution. If you know population standard deviation, you use the z-scores.
Mhm.
In this problem, we don't know.
How do you know when to use the one tail versus two tails? Because you do still show the 0.05 in both.
There you go. It depends on the alternative hypothesis. What is it in the alternative hypothesis? Here is less than means left tail, greater than means right tail, and not equal to means two tail, both tails.
Thank you.
Mhm.
So sometimes you have to divide the I'm sorry, I forget what it's called, the 0.05, you don't have to divide the to make two tails.
Yeah, if it were to be a two-tail test, then you divide this 0.05 by 2,
Okay.
but it is a one-tail test, so you just leave it as it is.
Okay. Yeah.
Okay, next problem. Okay, so for this one, let's see what is the mean and the standard deviation. I have that one. Let me check. It's L3. Okay, mean is 19.88 X bar. (19.88) and your sample standard deviation is 8.38. 8.38. So now, okay. You'd like to know how many hours on the average a student at your school works per week. So you are 17 people, so your N is equal to 17, right? And got the following data. And the mean of this data is 19.88. Standard deviation of this data is 8.38. Assuming normality, that means you are assuming bell shape. Test the claim that the mean number of hours students work is more than 15 hours. So you're testing either mu is greater than 15 versus mu is less than or equal to 15. And your alpha is 0.05. So let's go ahead and do the problem. Number one, normality condition is given in the problem. Yes?
I was gonna ask, is this a two-tail or one-tail problem?
So you tell me. So H naught is mu is less than or equal to 15, and H sub A or alternative hypothesis is mu is greater than 15. So you tell me which tail is it? Right tail, left tail, or both tail?
Is it right tail?
Yeah, it's greater than, meaning it's right tail.
Okay.
The best way to figure it out is look at the symbol that's right after mu. Is it pointing left or is it pointing right? And then you'll know which side you're using. And if it's just an equal sign with a line through it, basically not equal to, it's going to be two tails because you're going to have to measure both sides.
Yes, exactly. There you go. Don should be the teacher. Right, Don?
I don't know about that.
No, you explained it wonderful. Easy way, simple way. Because I have been teaching this stuff for so long, I feel that I try to teach it as easily as possible, but sometimes students think that, oh, maybe it's not so easy for them. Because, for me, I have done it so many times that it comes to me naturally. But for somebody who is learning it for the first time, they don't see it as easily, right? This is very normal. So
yeah, and I can understand where he's coming from because I was confused about that at first, but then when you explained it earlier, it made sense. So I'm a very kinesthetic learner, so I have to look at all of the details and see it actually happen in order for me to understand it.
Yep. All right. So X bar is 19.88, right? X bar is 19.88 minus mu is 15. All of it divided by S, which is 8.38 divided by the square root of the sample size, which is 17. And if you do the math, what do you get? 4.88 divided by 8.38, 8.38 times square root of 17, which is 2.4. 2.40. Now we are going to go ahead and do the other parts. Again, very standard process. You find the critical region, critical values for T. Remember, T distribution is a bit kind of stretched. 0, and it's a right tail test. Alpha is equal to 0.05. So area to the right is going to be 0.05. And your degrees of freedom, by the way, is going to be n minus 1, means 17 minus 1 is 16. Again, you look at up in the table for degrees of freedom 16, and you go to the fifth column, that's going to give you 1.746. 1.746, yeah. So your critical region is going to be everything to the right. 1.746 all the way up to infinity. And step number 5, your conclusion. And the T star 2.4 is probably going to be somewhere here, right? 2.4. So T star is equal to 2.4 is in critical region 1.746 to infinity. So what do we do? What is it we should be doing?
Reject.
You reject the null hypothesis. Reject H naught, which is what? Mu is less than equal to 15. Very, very simple, very standard, nothing magical. Very routine. You follow the process, you get it. Are you guys feeling okay with it?
Yeah.
All right. The next one is the last problem from this group. I did the mean and the standard deviation for my last class, but I don't have it, I forgot. So if anybody could do the mean and the standard deviation for this quickly. Don, I saw you referring to a website.
Yeah, the calculator probably gonna take me a little longer.
Yeah, so just enter these numbers, please, and give me the mean and the standard deviation. So you'd like to know how much money on the average students spend on coffee and snacks at your school per week, by the way. There are two typos here, not per work per week. It should be per week. How much they spend? So you asked 13 randomly selected students, so n is equal to 13, and you found these numbers. And it's going to give you an X bar, and it's going to give you a standard deviation S, sample standard deviation. At point alpha is equal to 0.05. Alpha is equal to 0.05. At that significance level, what do you get? So can you test the claim that the average amount of money a student spends is greater than $20 per week? So mu is greater than 20 versus mu is less than or equal to 20. Mu is greater than 20 versus mu is less than or equal to 20. Okay. All right, let's see what you got done.
So it looks like I have the mean as 29.54
Okay,
and the standard deviation is 8.98.
8.98 or something else.
I have, it says standard deviation. Maybe I'm reading the wrong one. It says 8.98.
It's supposed to be 9.35 if I'm not mistaken.
Let me see if I have all the numbers correct.
Your average is correct, so how could the standard deviation be off?
Yeah, that's weird. What do you have as your standard deviation?
9.35. That's what somebody has. Now I remember from the last discussion, it was 9.35. Depending on how it is possible that they divided by n as opposed to dividing by n minus 1.
It's possible.
Yeah, okay.
Oh, you know what it is? I figured it out. So on the
What is it?
calculator, I had it set on population and not sample, and that's why I did that.
Yep. There you go.
Sorry, I'm still running a bit of a fever from that COVID vaccine, so
Okay, hopefully you'll feel better soon. Give it 24 hours. By the way, new COVID is in the Bay Area, so everybody be careful. Okay, do social distancing and everything. And this one is very infectious. That's what I hear. So be very, very careful. Okay, so now your number one is bell shape. It says problem. Okay, given. Number two, mu is less than or equal to 20. That's your H naught. Okay, and H sub A is mu is greater than 20. Number three, your test statistic T star is equal to X bar minus mu divided by S over square root of the sample size. So T star is equal to X bar is, what is it? 29.59 minus 20 is the mean, divided by S is 9.35, divided by the square root of the sample size. What is the sample size? 13. So if I did the math for this, I would get
I got a 3.68.
9.59. So let's see.
Your X bar is off. It's 29.5. Oh, you rounded up. Never mind.
Okay. 9.59 divided by 9.35. 9.35.
Is that a 4 or is that a 9?
13. That's a 9, if I'm not mistaken.
Okay, I thought that was a 4 at the start.
It's 3.698 or 3.7. $3.70.
it was supposed to be 29.54, Mr. Hussein.
Oh, it's supposed to be 29.54?
Yeah.
Okay. I'll live with that error. You guys get the idea, right?
Yeah, I understand it.
Yeah, it's gonna make a very small difference, I think. I think we're still gonna be pretty much the same thing. If anything at all, very, very small difference. And it's not gonna be, anyway, that's not gonna make a significant difference. All right, number 4, your critical region. So T distribution, a little bit stressed. 0. And do I do right tail? Yes. What is the alpha? Alpha is 0.05. And degrees of freedom is n minus 1. That is 13 minus 1 is equal to 12. So So if you look it up on the table, degrees of freedom 12, and area in one tail is 0.05, area in two tails is 0.10, is going to be 1.782. So it is 1.782. So your critical region is going to be everything from here to the positive infinity. So 1.782 to positive infinity. Now step number 5 is gonna be your test statistic, right? T star is 3.70, which is probably gonna be somewhere here, 3.70, right? Is in critical region, right? Infinity. So reject H naught. It's in the critical region. H naught is mu is less than or equal to 20. Any question? Anybody, any question I could answer? Does it make sense?
It makes sense to me.
Yeah, it makes sense.
Okay, in that case, that's kind of the conclusion for hypothesis testing
I
or
just want to clarify.
population mean when you do not know sigma. That's pretty much all I wanted to do. I have done 4 different examples, going through the same process 4 times for one case, and then I went through the same process another 8 times with 2 different hypothesis testings, one for proportion and one for mean when sigma is known. So you have seen it about 12 times or so, similar process being done. Hopefully it is sticking to your head, and hopefully you will be okay. If you forget any of the steps, watch the video and you should be good. All right, somebody was saying something. Go ahead, please.
Sorry, I just wanted to clarify so I can understand it better. When you define if there's 2 tails or 1 tail, you have to like check if it's on the right or the left.
You have to check whether it's the right side you're testing, like greater than, like the way Don said, right? If it is to the right, this symbol greater than, then you do the right tail. If it is to the left, you do the left tail. On the other hand, if it is not equal to, then you have to do both tail. In that case, you have to divide alpha by 2 and distribute it accordingly.
Okay. All right, that makes sense. Thank you.
Mm-hmm. Okay, folks, that's all for the night, for the afternoon or evening. And have a good weekend. Stay safe, stay
Good
healthy.
one. Thanks for everything. Bye.
Okay.
See you
All
on
right.
Monday.
Bye.
Have a good one.